Welcome to David Alexander Maths Tuition. This is chapter 14a on exponential functions. So sketch the graphs of 3 to the x, 5 to the x and 7 to the x. So if we consider some x values of 0, 1, 2 and 3, we're going to get corresponding y values of 3 to the 0, 3 to the 1, 3 squared and 3 cubed. Now 3 to the 0 is 1. Anything to the power of 0 is 1. 3 to the power of 1 is 3. 3 squared is 9 and 3 cubed is 27. So as the x values are going up in 1, but the y values are plus 2, plus 6, the y values are sort of getting a bit out of control. So we are going through 0, 1, and then what that means is this graph is just going to take off and it's getting very steep very quickly. Let's have 5 to the x, so 0, 1, 2, 3. So 5 to the 0 is 1, 5 to the 1 is 5, 5 squared is 25, 5 cubed is 125. So we can see that y to the 5x is also going through the point 0, 1, but although the x's are going up in ones, the y is getting even more out of control, so this would mean it's getting even steeper than y equals 3 to the x. So 7 to the x, again, it would go through the point 0, 1. So the key thing we need to remember is anything to the power of x always goes through the coordinates 0, 1. And if we're comparing 3 to the x to 5 to the x and 7 to the x, then 3 to the x will be the least steep, or 7 to the x will be the most steep, 5 to the x will be the next steep, and 3 to the x, as I said, will be the least steep. So which of these is the least steep here? So this is 3 to the x, this is my 5 to the x, oops, not 5x, this is 5 to the power of x, and this is my 7 to the power of x. And notice that they all go through this point coordinate here, which is 0, 1. Okay, so sketch the graphs of y is 3 to the x, 5 to the x, 7 to the x and 1 to the x. Well, we've just seen 3 to the x, 5 to the x and 7 to the x. What about 1 to the x? So for x values of 0, 1, 2 and 3, 1 to the 0, anything to the power of 0 is 1. 1 to the power of 1 is 1. 1 squared is 1. 1 cubed is 1. So here the y value is always 1. So we need to remember that 1 to the power of x is actually a straight line. So if this is 7 to the power of x, this is 5 to the power of x, this is 3 to the power of x, 2 to the power of x would be less steep, 1.5 less steep still, 1.25 x really perhaps not that steep, and then we're gradually getting down to the point where we're getting to 1 to the power of x, which is so unsteep that it's actually a horizontal line. So remember that y equals 1 to the power of x is the same as the line y equals 1 basically. Okay, so if we're sketching some graphs, we know that y equals 2 to the x will be a fairly steep like so. 1 to the x we know from the previous slide is a straight line, again going through 0, 1. So what about 1/2 to the x? So we're going from 2 to the x down, which is going upwards, 1 to the x which is now horizontal, then 1/2 to the x, that will be going in the other direction, although that's there we go. So y equals 1/2 to the power of x, going again through 0, 1. So, and one thing that is important to notice is that 2 to the power of x is a reflection of 1/2 to the power of x. So this is 2 to the x, this is 1 to the power of x, i.e. y equals the line y equals 1, and this is y equals 1/2 to the x, and as we can see that is a perfect reflection of 2 to the power of x in the y-axis. The function f of x is defined as the f of x is 2 to the x, and on the same axes we need to sketch 2 to the x and 3 times the f of x. Okay, so 2 to the power of x we know goes through 0, 1. The x-axis is an asymptote, which I may not have mentioned before and probably should have done actually. So all we need to show is that it's going through the point 0, 1. Oops, there we go. And it's going upwards, it's getting steeper and steeper like any exponential curve will do. Now 3 times the f of x means we are tripling all the y values. So what this is a stretch with a scale factor of 3 parallel to the y-axis. So we're just stretching it in this direction. So instead of it going through 0, 1, it's now going to go through 0, 3 times 1, so it's going to go through 0, 3. Okay, and every y value will be tripled, so it's going to get well, it's going to get much steeper much quicker. There we go. Sorry, that's a fairly terrible sketch there. So, but the key thing here is this is 2 to the x, so it's going through at 0, 1, and our sketch of 3f of x, we can see it's going through at 0, 3. Okay, so here we want to be showing the graphs of 2 to the x and 2 to the x plus 3. So all this means is this is a transformation which is taking place outside the bracket, so therefore it's affecting the y values. So all we're going to be doing is moving the whole curve up 3 units. So here is 2 to the power of x going through at 0, 1, and the x-axis is the asymptote. So that's the line where y equals 0. So if I'm moving everything up 3, so that means everything including the asymptote will move up 3. So here is my asymptote, which is the line y equals 3. My y-intercept won't be 0, 1, it will now be 0, 4. And again, there we go. That is all we need to show. We don't need to worry about anything else, just the equation of the asymptote and where it's cutting through on the y-axis. Okay, so for this question we're just comparing the f of x and the f of x minus 2. So here the transformation takes place inside the bracket, so it's affecting the x's. We do the opposite of what it says, so we're adding to all the x values, so that means it's going to be a horizontal shift 2 units to the right. So first of all, let's do 2 to the x. The key thing is the x-axis is an asymptote and it's going through 0, 1. Okay, so if I shift everything 2 units to the right, it's not going to go through 0, 1. We know it will go, instead of going through 0, 1, we know that it's going to go through the point 2, 1, although we're not perhaps too stressed about that. So we just move the whole line 2 to the right, and it will look like so. Again, there'll be no change to the asymptote. It will still be the line y equals 0 or x. We don't know what the y-intercept will be, although we could of course work that out, but if we're just doing a sketch, we're just showing that this is just going through 2 to the right. I mean, the key thing here is understanding that it's exactly the same line, and it's just shifted 2 units to the right. That's really the key thing in this question here. Okay, here it is a little bit more neatly. So here is the f of x. So this is 2 to the x, and this is 2 to the power of x take away 2. So as you can see, everything has just been shifted. So 0, 1 is now 2, 1. Everything has just been shifted 2 units to the right, and the x-axis is still the asymptote. Okay, so the graph of y equals k a to the x passes through these 2 points. Find the values of the constants k and a. Okay, so we know that x is 4 and y, when x is 4, y is 5, 6, 7, and when x is 5, y is 1701. So let's just substitute these into the 2 equations. So if y equals ka to the x, then 567 equals ka to the power of 4. And using the other set of coordinates, we know that 1701 equals ka to the power of 5. Okay, so what I'm going to do is k is common to both of them, so what I'm going to do is make both of these equal k. So 567 over a to the power of 4 is k, and 1701 over a to the power of 5 is k. So if k is both this and this, then these two things must be the same. So 567 over a to the power of 4 must equal 1701 over a to the power of 5. So let's cross multiply. 567 a to the power of 5 equals 1701 a to the power of 4. We can divide both sides by a to the power of 4. So 567a is 1701. So a is 1701 divided by 567. So 1701 divided by 567 is 3. So a is 3. And now we can go back and work out what k is using either of these equations. It doesn't really matter, but I'll use 567 over a to the power of 4, 567 divided by 3 to the power of 4, so k is 7. So a equals 3 and k equals 7.